It is, it's a nearly universal frustration that I think everyone listening has definitely experienced. You ask an AI a question, and it just confidently hands you an answer that is completely spectacularly wrong.
Oh, yeah, totally. And it just says it with such authority, right?
Exactly. But if you actually look at the math behind it, generating the truth is twice as hard as simply recognizing it.
Right, which is wild to think about.
It really is. So today, we are doing a deep dive into why these models aren't, glitching when they confidently lie to you. They're actually doing exactly what they were mathematically programmed to do. We're dedicating this whole discussion to unpacking the architecture of an AI hallucination.
And we've got a really fantastic stack of sources for this one.
Yeah, we're pulling from a deeply revealing new paper from OpenAI researchers, including Adam Kai. Plus, we have some great under-the-hood insights from Anthropic, the makers of Claude.
And we're tying it all together with foundational theories from AI pioneer Jan LeCun.
Right. So our mission today is to really demystify these confident lies. We want to figure out, where are they actually born inside the neural network? Why are our human training methods utterly failing to squash them? And, well, how is the industry trying to fix it?
It's a huge problem.
It is. Okay, let's unpack this. Because before we can talk about solving hallucinations, we have to look at the statistical reality of where they originate. And that takes us all the way back to the pre-training phase.
Yeah, so the pre-training phase is it's where the model is digesting its foundational data set. We're talking trillions of tokens scraped from the entire internet.
Right, the absolute massive core data.
Exactly. And the fundamental mechanism driving these models during this phase is autoregressive prediction.
Which basically means it's just predicting the next token, right? Since you all follow the space, you've probably heard that phrase a million times.
You definitely have. But the crucial part is, how it predicts it. The model doesn't just pick a word. It samples from a massive probability distribution for every single token it generates.
Which opens the door for errors.
Huge errors. And this is where Jan LeCun points out a critical structural flaw, which he calls exponential drift.
Right, because it's sampling from this probability matrix. Every single time it outputs a token, there is a non-zero probability that it just makes a mathematically suboptimal choice.
Yeah, it selects a token that might be, factually off base, but statistically very plausible within that specific context window.
And then what happens? Does it just move on?
No, that's the problem. That single suboptimal token subtly poisons the context window for the next token.
Oh, wow. So the errors compound.
Exactly. They're sequential. By the time the model hits, say, token number 20, the probability space has skewed so far from factual reality that it's essentially just generating high-confidence fiction.
So the probability that the entire answer is drifting into complete nonsense just increases exponentially the longer the output gets.
That's exponential drift in a nutshell.
I always try to visualize this like a jazz musician or maybe a freestyle rapper who is deeply in the flow state.
Ooh, I like that analogy.
Right, like you're improvising on stage and suddenly you hit a totally sour note. But you can't just stop the track and apologize to the audience.
No, you have to keep going.
Exactly. You have forward momentum, so you confidently play right into the mistake. You build the next phrase around that sour note, and you just try to make everyone think you meant to do it all along.
Well, it's funny you say momentum because the team at Anthropic found the literal computational equivalent of that jazz musician. And they explicitly call it momentum.
Wait, really? They use that exact term?
They do. They observe that once an AI model begins generating a response, its internal state develops this sort of painful compulsion to finish the sequence.
A painful compulsion. That's so descriptive.
Yeah, it is. The architectural drive to just complete a sentence grammatically and syntactically is overwhelming.
So even if it realizes it messed up.
Exactly. Halfway through the sentence, the model's internal activations might actually reflect that it lacks the factual data to finish the thought accurately.
But it just can't stop itself.
Nope. The momentum of those previous tokens just carries it forward. It confabulates the rest purely to resolve the syntax.
That is fascinating. And the OpenAI paper brings some heavy mathematical proofs to back this up, right?
Yeah, they get pretty deep into the math using a binary classifier model.
Yeah.
They essentially looked at the statistical burden of generating language versus just recognizing it.
And what they proved is wild. The generative error rate, which is the rate at which a model makes a mistake while creating a sequence from scratch, is fundamentally always at least double the misclassification rate.
Which makes perfect sense when you think about it, because the universe of invalid permutations is practically infinite.
Right, there are a million ways to be wrong.
Exactly. If you hand an AI a completed mathematical proof and you just ask, hey, is this valid? The model only has to parse a finite existing sequence. It's evaluating a binary state.
Yes or no? True or false?
But generating that exact same proof from a blank prompt, that requires navigating millions of branching probability paths without stepping off the factual ledge once.
The spelling example in the sources highlights this perfectly, I think. Models are incredibly good at spelling, right? Because it acts like a binary task.
The string of characters is either a valid word or it isn't.
Right. But if you take that same state-of-the-art model and ask it to count the number of Ds in the word ladder, which sounds so simple, it often fails catastrophically.
Because counting requires generating a sequential, logical process.
Yeah. It's an entirely different, vastly heavier statistical burden than just simply recognizing a pattern.
So we've got this base model that is essentially mathematically doomed to drift during pre-training.
Right. The token sampling practically guarantees it will eventually hit that sour note and just jazz solo into total nonsense.
But, that ignores the entire second half of its education.
Exactly. Because we spend millions of dollars and thousands of compute hours on post-training.
Specifically RLHF, right? Reinforcement learning from human feedback.
Yeah. We do all this to refine the models. So the obvious question is, why doesn't that post-training process simply teach the model to stop, evaluate its own uncertainty, and just say, I don't know?
Well, the OpenAI paper's central thesis tackles exactly this, and they argue that this isn't actually a technical limitation of the neural network at all.
Oh, then what is it?
They call it a sociotechnical problem.
Okay, what does that mean?
It means we have fundamentally trapped these AI models in a permanent test-taking mode. And we're the ones incentivizing the hallucinations through our grading rubrics.
Oh, I see. Bring us back to high school for a second. Think about sitting down for a standardized multiple choice exam, like the SATs.
I still have nightmares about those.
Right. But think about the strategy. If you come across a question you don't understand and you leave the bubble blank, you receive a guaranteed 0.
But if you guess completely blind, you have, what, a 25% chance of getting a point?
Exactly. The system is structurally designed so that the optimal, most rational strategy is to never abstain. You always guess.
And that is exactly what we are doing to AI. The industry relies on these massive standardized leaderboards to rank models.
Right. These are the benchmarks you always hear about. MMLU, Math, SWE bench.
Yeah. And almost all of these benchmarks utilize a strictly binary 0 to 1 scoring system.
So the model gets 1 point for a correct answer and 0 for a wrong answer.
Right. But crucially, it also gets 0 points if it outputs, I don't know.
So it's punished for honesty.
Exactly. The only major benchmark currently deviating from this is WildBench.
That's incredible. So we are training the gradient descent process to literally optimize for bluffing.
Yes, we give the model absolutely no reward for expressing uncertainty.
There's a great example of this in the OpenAI paper. They use their lead author, Adam Kai, as the test subject.
Oh, the birthday example.
Yeah. Let's say his birthday is just a single occurrence fact in the trillions of tokens of training data.
Highly obscure.
Very. The statistical expectation is that the base model will hallucinate on at least 20% of those highly obscure facts.
And because the model's reward function is basically terrified of leaving the proverbial bubble blank, it just refuses to state that it lacks the data on Adam Kai.
It just blurts out January 1st or September 30th.
Because in test-taking mode, a highly specific guess maps to a higher potential reward than a vague abstention.
It's just playing the odds.
Anthropic documented the exact same behavior with Claude. They asked Claude for research papers authored by a real researcher named Jared Kaplan.
And what happened?
Well, the model lacked the specific data in its weights. But because its reinforcement learning heavily weighted being helpful, which to the AI translates to providing a long, populated sequence, Claude fabricated non-existent papers.
Just entirely made them up.
Entirely. Complete with full titles and proper academic formatting. If we connect this to the bigger picture, the OpenAI researchers explicitly contrast this standardized test-taking environment with the school of hard knocks.
Human learning in the real world works completely differently.
Exactly. If you're a doctor or an engineer and you confidently spout absolute fabricated nonsense, you suffer severe reputational damage.
Yeah, you'd be fired. Admitting uncertainty and consulting a reference is actually highly rewarded in the real world. It builds trust.
But an AI has no real-world reputation. It doesn't experience the social penalty of being exposed as a fraud. Its entire existence is optimized around maximizing that one benchmark score.
Wait, if human engineers are fully aware that this multiple choice grading is so flawed, why don't they just change the RLHF data?
How do you mean?
Like, why not just fine-tune the AI extensively on adversarial prompts? Just feed it thousands of trick questions until the internal weights map perfectly to knowing when to abstain.
Yeah, it sounds simple, but Jan LeCun explains exactly why that brute force approach fails. He calls it the curse of dimensionality.
The curse of dimensionality.
Right, because the latent space of human language is practically infinite. During post-training, human graders give a thumbs up or thumbs down to specific model outputs, right?
Yeah, the RLHF process.
And that creates these safe, mapped zones within that latent space.
Yeah.
Engineers can easily fine-tune an AI for the fat part of the bell curve.
So, like, the 80% of common tasks. Drafting emails, summarizing text, that sort of
Yeah,
thing.
exactly. The AI learns the behavioral guardrails for those specific coordinates in the high-dimensional space.
But human curiosity represents this massive long tail.
Huge. The permutations of all possible queries you might ask an AI are so vast that it will inevitably encounter edge cases it has never, ever mapped.
And because the AI isn't learning a universal rule for truth, it's just memorizing localized patches of acceptable behavior, it only takes a slight deviation to step completely off the safe path.
LeCun points out that you can take a perfectly conditioned, safe AI and break it simply by swapping a few words into a foreign language.
Wow, really?
Yeah, or even prefixing the prompt with a string of random characters. You force the model's activation into an unmapped coordinate in the wilderness. The behavioral guardrails vanish, and it just reverts to being a broken lookup table generating total nonsense.
So you really cannot fine-tune for infinity.
You can't.
And, thinking about the sheer scale of the latent space brings up a totally different angle. Do we even want to completely cure the model's ability to drift?
That's a great question.
If you mathematically prevent the AI from generating tokens outside of its strictly proven factual database, you completely kill its utility as a creative engine.
That is a crucial nuance.
Yeah.
If you prompt an AI to write a science fiction script or brainstorm a totally novel scientific hypothesis that doesn't exist in any research paper yet, you actually require the model to confabulate.
Right, you need it to pull disparate low-probability tokens together. You are literally asking it to imagine.
And if it rigidly adhered to only proven facts, you would be useless for ideation.
So the hallucination is actually a feature, not a bug, depending on the context window.
Exactly. The researchers argue the goal isn't a lobotomy. We don't want to destroy the generative creativity. The actual goal is behavioral calibration.
Behavioral calibration. So the model needs the architectural capacity to align its internal confidence with its output accuracy.
Right. When generating a sci-fi story, it should lower its certainty threshold and freely connect abstract concepts.
But when you ask it for the dosage of a pharmaceutical, it needs to recognize it has entered a high-stakes domain, evaluate its probability matrix, and accurately signal when it lacks the data. We need to keep the creative jazz musician, but we need the model to know when it's time to play literal sheet music.
Perfectly said.
So how do we fix the system? We know we can't fine-tune for infinity, and we know the binary 0 to 1 grading rubric is actively incentivizing the bluff.
Well, the structural fix proposed in the OpenAI paper is a complete overhaul of the leaderboards. They call it moving away from the false dichotomy and adopting a false trichotomy.
A false trichotomy. Okay, so we have to change the reward function.
Exactly. Instead of just right or wrong, the proposed scoring gives +1 point for a correct answer and 0 points. Or ideally, a slight positive reward, like plus 0.3 for outputting, I don't know.
Okay, so it gets a tiny reward for honesty.
Yes. But then it introduces a harsh negative penalty, such as a -1 or even a -3, for guessing incorrectly.
Wait, if you introduce a harsh -3 penalty for guessing wrong, don't you just create an incredibly timid AI?
What do you mean?
Like, the gradient descent is going to optimize for safety, and the model will be absolutely terrified to answer anything unless it has a 100% statistical probability. It will just say, I don't know to everything to protect its score, which completely ruins its helpfulness.
And that is the exact tension the developers are trying to balance right now.
Yeah.
Which is why the false trichotomy has to be paired with explicit confidence thresholds during the reinforcement learning stage.
Okay, so you don't just punish the model blindly.
No, you program a strict mathematical constraint, something like only generate a factual response if your internal probability distribution shows greater than 75% confidence. Otherwise, Output, I don't know.
Ah, so this forces the model to actually evaluate its own activations before generating the first token.
Exactly.
And we are already seeing the frontier models testing this architecture. There was a recent interaction with an early version of OpenAI's GPT-5, where the model spent 34 seconds in a visible thought process.
Right, evaluating its own latent space and probability distributions.
Yeah, and the final output after all that thinking was simply, I don't know, and I can't reliably find out.
Which is a response that actually builds user trust.
Absolutely.
And Anthropic's technical notes also provide some incredibly practical methods for listeners to manually trigger this behavioral calibration right now. You don't have to wait for the entire industry to update its benchmarks.
I really want to highlight these because you can alter the AI's reward function simply by changing how you structure your prompts today.
The first method is giving explicit permission. Tell the AI upfront in your system prompt, it is okay if you do not know the answer. Please prioritize accuracy over helpfulness.
So you are manually giving it that plus 0.3 reward for abstaining.
Exactly. You can also explicitly ask the model to output its internal confidence level alongside the fact.
The most fascinating tip they shared, though, was about breaking the momentum.
Oh, this is crucial.
If you ask an AI a complex question and it spits out a highly confident answer complete with academic sources, do not ask that same chat window to verify if the sources are real.
Because the context window is already polluted with the generated tokens.
Yep.
The painful compulsion to maintain syntactic consistency will actually force the model to defend its previous hallucination.
It just doubles down on the lie.
It does.
So you have to open a brand new, completely blank chat window. You paste the generated text in and you ask the fresh instance of the model, can you verify if these specific sources actually exist and support these claims?
By doing that, you strip away the momentum.
The new instance doesn't have the statistical baggage of having generated the first sequence.
Right. So it can evaluate the text strictly as a binary classifier.
Mm-hmm.
You are forcing it into the discriminative task, which, as the math proved earlier, is significantly easier for the model to execute accurately.
So what does this all mean? The biggest takeaway here is a necessary shift in how we conceptualize these tools. We really have to stop treating large language models like omniscient, magical oracles pulling truth from the ether.
We need to interact with them as what they actually are. Brilliantly articulate, highly capable test takers who have memorized vast amounts of data but are absolutely terrified of getting a bad grade.
It is on the developers to rebuild the grading rubrics, but it is on you, the prompter, to give the model permission to admit its own ignorance.
The models are performing exactly as they were optimized to perform. The hallucinations are a compounding mix of the statistical token drift inherent in pre-training, colliding with a flawed multiple-choice reward function that actively penalizes honesty.
We've covered how to incentivize the models to finally say, I don't know, but I want to leave you with a completely different implication to mull over. Let's assume the industry successfully implements the false trichotomy. The models now possess strict confidence thresholds, and they gladly output, I don't know, to protect their scores whenever the probability matrix looks muddy. If that becomes the standard architecture, will bad actors start exploiting it?
Wait, how so?
Think about data poisoning. An adversary wouldn't even need to successfully teach the AI a specific lie anymore. They would just need to inject enough contradictory noise into the training data to flatten the model's probability distribution.
Oh, wow.
Right. If you muddy the waters just enough that the AI's internal confidence drops below that 75% threshold, you force the model into a permanent state of automated paralysis.
The AI simply refuses to answer questions about specific historical events or technical facts because it's too risky.
Exactly. Does fixing the hallucination problem accidentally create a massive vulnerability for denial of service through apathy? It's something to think about the next time you find yourself wishing your AI was a little more cautious.